Now let's move to our next type, which is records. And this one is also very important. Now, a record is a special kind of class introduced in Java 14 as a preview feature and made permanent in Java 16. It is designed for one job, being a transparent, immutable carrier of a fixed set of values. So records eliminate the boilerplate that every data class used to require private final fields, canonical constructor, accessors, okay, hash code are all generated automatically. Okay. Now records are the right tool for DTOs. Okay. This one is related to our development, data transfer objects. Okay. Basically, this one is an object that carries data between different parts of our application. Okay, like between our API and our database layer. For now, just skip this. This one you can assume this one is just one object, okay, that carries data. So records are the right tool for that. API response objects, configuration bundles, okay, value objects, and anywhere you want just the data without writing 40 lines of ceremony. And we will see. Okay, now the problem records solve a simple pair of fields used to require a wall of code. Let's say we want just getter methods, okay, and some equals or hash code or toString, simple thing. All right, we can achieve these kind of things inbuilt from our records declaration. All right, now you can see here we have one equivalent line to all these lines with our record help. Okay, so here we are generating private final fields, okay, for this name and age. And we will also generate our constructor, right, like that, exactly same. And we will also generate our accessor methods or getter methods, these. All right, we will also override our equals, hash code, and toString. So by default, we are getting all these things from this single line. Okay. Now, what you get automatically, generated member, private final fields, okay, description, one per component in the record header, canonical constructor, public accepts all components in declaration order, accessor methods, and these, okay. Now let's see one example, public record person, this one, and accessor methods you can call, right? Now, if you have noticed, generally we create our getter method something like get and then name, okay, so like that, get and then name, okay, field name. But with record we will get exactly same name as our fields, okay. So this one you cannot call here get name, okay, you can call directly on this name. This one is one difference, equals compares by components, new person, this one equals this. Okay, so we have ls2 this one and ls1 this one, or ls we can call equals true, hash code true. All right. So here we are basically comparing all components. Okay, so all fields. All right. And this one hash code is also based on all components. Okay. Okay, so let's see. We can create here one record, or we can make this public, but that's not necessary here. Record, let's create person, string name, and age. That's fine. Now here we can create instance directly, okay, person, okay, John 20, that's fine, person.name, okay. We can also call person.age, person.toString, right? Or we don't have to do that as well, unnecessary call, we can just print directly, and by default we are calling here toString method. All right, now let's compile this and just run this one. So we got this output. Okay. All right, now next one is compact constructor, validation without boilerplate. Data objects often need validation, right? Like rejecting negative ages, blank names, nonsense values. So a compact constructor gives us a place to do this without restating the parameter list. This one is one compact constructor. Okay, no parameter list, no field assignments, because our Java will handle the field assignment after our code runs. Okay, so this one, if name equals to that or name this one, we can throw one exception, something for age as well. Okay, here we can also reassign parameters to normalize them. Okay, so two features make compact constructors concise. There is no parameter list. Okay, the parameters are implicitly the records components, and field assignment, something like this dot name equals to this and this, happens automatically after your code runs. And you only write validation and normalization logic. Okay, so you only have to do this one. Now, if you create your instances, then for that you will get one exception. Okay, let's see, just copy this one, and I guess we are good. And if we create here with empty string, now let's see. Okay, no compilation error here. Run this one and we got this exception, okay, that we are throwing here. So in additional to this constructor, we can also have methods. Okay, adding methods. A record is a class. Okay, so we can add some regular methods, static factory methods, and also constants. So let's say you have this record. You can add here these methods. Okay, perimeter and static factory for a common case. And you can call this one directly on your record name. And here we are returning new instance. So that's fine. Static constant, public static final rectangle unit. Okay, new rectangle, this one. Now create instances and r.area, you will get this perimeter, you will get this. Okay, and you can call this square directly on your record name, and you will get new instance here from here. Okay, and here one more thing, why we are doing that? Okay, because our records are immutable. Okay, so we have to return one new record here. Now next one, implementing interfaces. So records cannot extend classes, but we can extend or we can implement interfaces, right? So let's say we have this interface, and here we have to provide implementation for that. So we can do that here. Now we can create instance and we can call this method. Okay. So this makes records a natural fit for modeling data that needs a specific capability, such as comparable for sorting or printable for formatting. All right. Now next one is nested records. Records can be nested inside classes, interfaces, or other records. And nested records are implicitly static. So public record, nested record, implicitly static. That means you can call on this one. Okay, so order dot item, right? Item equals to new order dot item. So you can call, if you have to create instance of this one, then you can call on this one. Nesting is useful for types that exist only in the context of their outer type and should never be used independently. Now next one is records with pattern matching. This one is important, and we call this one modern feature of Java. So records work especially well with pattern matching in Switch, and let's say we can deconstruct a record into its components as part of a type check. Okay, so components are just fields. Okay, now you can take a look here. Okay, so sealed interface, we have not covered this one. Basically, if we declare directly interface, let's see here. Okay, so now let's say normally we do interface, right? And then let's create this one with name A. Okay, now here we have method void A, abstract method. That's fine. Now we can extend or we can implement this interface anywhere, right? Let's say class B implements A like that. But what if we want to control hierarchy in case of interfaces as well, right? So we can write here sealed. We can seal our interface. Okay, so sealed interface. And now every sealed interface must provide like who they are giving access to. So here permitting permits B. Okay. Now this one, all sealed class subclasses must either be final, sealed or non-sealed. Right. Now we are giving access to B. And now if you can see here, we can extend this class. Okay. In any case. Okay. So now what's the purpose of sealed interface here? That means we have to do something here as well. We have three choices here because we are controlling hierarchy through interface, right? And if we can extend this class, okay, from anywhere, then what's the purpose of shield interface here? That's why either we stop inheritance here by using final keyword, or we can mark this one shield again, okay? And for shield, we have to again provide here like which class we are giving access to, like permits that thing, okay? And let's create one another C. Okay, and we can create here final class C extends B like that. Okay, because Java wants to know exactly that what you are doing with this one shield interface. Okay, we have to know exact types or classes that we are working with this controlled hierarchy. All right, but we can also open here. Okay, so we don't have to mark this one final because final stops our inheritance. We can open this one, so non-sealed. Okay, now anyone can extend this one basically, and here we are controlling B or A here, but we are opening our inheritance here. So now we can extend this one from anywhere else. Okay, so this one is one thing about sealed interfaces. So in this one, let's say we have this shield interface shape. We have one interface shape, okay, that permits circle and rectangle. Now we have one record or basically one class, final class basically. And for sealed interfaces, we require either sealed or final class, okay, or non-sealed, okay. So we know that records are final. That means these will work here. So record circle, we can grant access here, okay. This one and implement shape also for rectangle. Okay, now this one is very important, also this one. So this one is normal pattern matching. Okay, so we know that this one is switch and we got that in Java 21. Okay, now here if this shape is of type circle, then we can call area this one pi r square. Okay, now for that we can call this one. Okay, but with record patterns or deconstruction of our records, we can see here if the case is circle, then we can extract its fields directly into variables. All right, like here are, and we can return this one. I know this one is a little bit confusing, but this one is important in case of you might be thinking. Okay, so here basically we don't require any casting or some getter calls. All right, our Java will handle those parts. All right. So overall, our record patterns are something we can do some type checking. Okay. We can do some destructuring, or we can also bind our variable, okay, into one single expression, right? So these are this one and this one are two advanced use cases of our records. Okay. And if you want, you can understand them. And otherwise, for normal use cases, just skip those things. We have some advantages, but we also have some limitations. First one is records have intentional restrictions that keep them simple and predictable. Restriction cannot extend another class, okay, because we know that records are implicitly final. Okay, records implicitly extend this one. Java does not support multiple inheritance. We know that. Okay, implicitly final cannot be extended, cannot declare instance fields. All state must be in the header. Okay, this preserves transparency. All right. So if you have a record here, I guess we can copy or we can write here. Let's say we have this record here, RA, this one. You cannot create here something and let's say ABC equals to 10. This one is not allowed. Okay. Instance field is not allowed in records. Cannot declare instance field, that's fine. No instance initializer blocks. Use the compact constructor for setup. Components are final. Okay, shallow immutability. A record's references are final, but the objects they reference may still be mutable. Let's say this one or this list. Okay, forbids reassigning members, but the list itself can still be mutated. Okay, via this one for deep immutability, make defensive copies in the compact constructor. And you can do that. And we will see this syntax in our collections. Okay, why this one is immutable. Okay, now we have some use cases. Reach for a record where the type is fundamentally a bundle of data, no complex life cycle, no mutable state, and two instances should be considered equal if their components are equal. Okay, and we want some pass or return a few related values together. Common fits perfect for DTOs and value objects such as this one, configuration bundles. Okay, and records are usually the wrong choice when the type has an identity separate from its data, an entity with an ID field where we want ID based equality, not field based. Okay, the type has mutable state. The type needs to extend a concrete class. Impossible for records. Okay, now we have quick differentiation between records and classes. So for boilerplate, records minimal one line. All right, mutability fields are final. Our choice inheritance cannot extend or be extended. Equals hash code auto generated from components intended use transparent data carrier. We have quick summary. Now we can move forward with our next chapter, which is nested and inner classes.